Okay, so one use of pointers to functions is to pass a function as an argument to another function. So in C, it's not possible to have a function within a function, but we can simulate that through the use of pointers to functions. Okay, so before I give you an example on how to do that, let's start first with a simple example on how to use or declare pointers to functions. So here in our example, we have two functions, main and strprint. So in main, we have one variable, or which is an array of char, which is initialized to the string pointing a function. And ptr here is actually our pointer to a function. So ptr is a pointer to a function that has a parameter of type pointer to char and returns a void. Okay, so meaning to say, we can assign addresses of functions to ptr provided that that function accepts a pointer to char as its argument and it returns a void. Okay, so in this next line of statement, we are actually assigning the address of strprint to ptr. So in effect, ptr and strprint are now aliases. So through ptr, we can also invoke the function strprint. Okay, so instead of calling strprint using the function name itself, we can now use the pointer ptr. Okay, so for instance, we can call strprint here. Oops, sorry. And pass the parameter str to the function. But another way of doing that would be to use our pointer to a function ptr. So this one and this one are actually the same. Okay, so when you have this one, it will also invoke the function strprint, and it will pass the parameter or the argument str to its parameter str here, which will display what is referenced by str, which is the string pointing a function. Okay, so that's how pointers to a function works. Okay, so again, ptr here is assigning the address of the function strprint, and they are now aliases. So we can also invoke the function strprint through ptr. Okay, now let's have a longer example. Here we have three functions: display, sum, and main. So in main, we have an integer array n that can accommodate or can store 5 integer elements. And using a simple for loop, we read the input through the keyboard using scanf and store it in our integer array. Then we invoke the function sum, whose job is simply to sum up the elements stored in our array n. But look at our function call here and the arguments included. So the arguments for our function sum consist of the function display and the array name n. Okay, so in C, it's completely legal to pass the name of the function as an argument, provided that the parameter that will accept this function name is a pointer to a function. So let's take a look at our function sum and the parameters that it has. So one of its parameters is actually a pointer to a function. So ptr here is a pointer to a function that can receive addresses of functions whose function accepts an integer array and returns void. Okay, so again, ptr here can receive or can hold addresses of functions provided that that function receives an integer array and returns a void. Okay, and it also has another parameter, which is a, which accepts an integer array, or specifically the address of our integer array. Now, if we call sum here, it's possible to pass display to our pointer to a function ptr, Why? Because the function display is perfectly compatible with our pointer PTR here, because display returns void and it accepts an integer array. If display returns float, for example, or returns char, or it has different parameter other than this, then display cannot be compatible with our pointer to a function PTR, and it will result to a compile time error. Okay, so here PTR and the function display are now aliases. So similar to the previous example, we can invoke the function display through PTR. So looking at the function sum here, so particularly in this line here, so instead of calling the function display through its name, okay, so for example, we will call display here, okay. Okay, so it becomes messy, and submit our array A. Okay, like that. Okay, just ignore that. So we can actually use the pointer to our function PTR and submit our array A. So what happens here is that display will be invoked and the flow of control will be transferred to the function display. So the address stored in A, which is the address of our array N, will be passed to N here, and it will, using the for loop here, it will display all the elements stored in our integer N. Then after doing that, the flow of control will be returned back to its caller, which is the function sum, and the for loop here will simply add all the elements stored in our integer array. And the sum, which is the last value of S, will replace the function call, and it will be displayed by the printf statement. Okay, so this is how we simulate a function to a function, by passing a function as an argument to another function through the use of a pointer to a function. Okay, now let's discuss about dynamic memory allocation. Okay, by the way, before I do that, let me show you first an example, which is actually an integration on how to use the array of pointers and pointers to a function. Okay, so supposing you are asked to write a program that can add, multiply, subtract, and divide depending on the user's choice. So you will present the user with a menu of the different operations, arithmetic operations. So, and the user will select, and whatever the user selects, so it will perform that operation. So ideally, what we do is use a switch statement. Okay, so supposing here we have 4 functions: add, subtract, multiply, and divide. Okay, all of them returns void. So here we have our menu and the prompt, prompting the user to input the number of his or her choice. Then we use a switch statement to cater to whatever input the user keys in. If it's 1, then it will call the add function and display the statement, this is function add. So if it chooses the third operation, which is multiply, and it will call the multiply function, which transfers the control to the function multiply and prints the statement. Okay, so it's very easy to do it this way, but it's not the only way to do it.